Okay, this is the math transitions video for the week of January 4th. I'm going to post this to Google Classroom as soon as I'm done recording, and then I'll post some homework problems for you guys to do as well. But this is just your reminder to make sure your sound is turned up so you can hear what I'm saying in the video. So turn that volume up, and just please know that at any time, obviously pause the video if you need to so that you can copy down a question, or you can rewind if you missed something. I'll have this posted as a video with a YouTube link so you can go backwards, forwards, stop and play whenever you need to, okay? All right, so what we're gonna do is I've circled some inequalities problems from a study guide that I have, and it basically covers everything that we did with inequalities in this unit so far. So this will wrap up the unit. Like I said yesterday, I need you guys to copy the problems down. Don't just answer them on your paper, but copy the problem down, pause the video if you need to, and then write your solution too. Whenever you get to the homework problems, if you have the questions and the answers, then you will know what to do if you get stuck. So the first four here, I'll try to keep this as brief as I can, but please email me if you have questions if I went too fast. The first four here are just writing an inequality using the greater than, less than, greater than or equal to, less than or equal to symbols. And then it's asking about, is a certain number a solution to that particular inequality? So for these types of problems, remember, if it's a filled in circle, it means that it's going to have that or equal to line underneath. And if it's an open circle, it's just greater than or less than. Okay, so if it's a filled in circle, it's going to include that number that the circle is on. So looking at this first one, I've got a filled in circle and an arrow to the left. Remember, less than is left. And it looks like this circle's right between 7 and 8. So I'm just going to use the variable x because that's usually my go-to, sometimes y. But this is going to be less than or equal to, because we have a filled in circle, less than or equal to about 7.5. We'll call that in between. Okay, so we're just writing the inequality. So would 7 be a solution to this inequality? Well, is 7 less than or equal to 7.5? Yes, it is. And if you're not sure, you're basically just taking that number, putting it where the variable is, because x represents any solution that is less than or equal to 7.5. So yes, 7 is less than or equal to 7.5. Let's look at number 2. We've got an open circle, so I know I'm going to have my variable x with a greater than or less than symbol. And it looks like this is on right here in between 0 and -1. So we'll call that maybe -0.5. But is it less than or greater than? Well, it's pointing to the right, so this is greater than. So x is any solution that is greater than -0.5. So would -1 be a solution? Well, is -1 greater than -1/2? No, it is not. So that answer is no. Okay, number 3. Open circle on -2. And this is kind of hard to see, but there is an arrow drawn to the right. So we have x is, right is greater than, x is any number that is greater than the number -2. So is -2 a solution? Well, it doesn't have a filled in circle, so we're not saying that it's greater than or equal to -2. So -2 would not be a solution. Okay. And number 4, last one for this type of problem. This is hard to see again, but we've got an arrow drawn to the left, so it's less than. Closed circle on +3. So x is any number that is less than or equal to +3. So would +3 be a solution? Yes. Okay, so that's what we started this unit with, was just basic graphing inequalities on a number line. Now this next part is where the algebra came in and we had to solve. I'm only going to do these two, so if you see a bunch of other problems on the page, I might skip around, so you only need to copy down the ones that I solve on the paper. So when we have a solution that we need to solve for, okay, we need to get our variable by itself. Right now the letter A is not by itself. How do we get it by itself? We do the opposite of what we see in the problem. So the opposite of multiplying by 3 is dividing by 3. Make sure you do that on both sides because it'll cancel out on one side. 18 divided by 3 is 6. So you have 6 is less than or equal to A. And that's your solution. But some people prefer to have their variable on the left. So if you want to switch things around, you can, but that means you got to flip this symbol around because it was originally opening towards the letter A. So our solution is A is any number greater than or equal to 6. So in class, we would put that number on our number line. We would make the appropriate circle, and then we would draw the arrow. So greater than or equal to 6 would be an arrow drawn to the right. Okay? One more of this type. I've got to divide again, but I chose this one because we are dividing by a negative number. So to get y by itself, okay, we're solving for y. We have to divide by that -4 on both sides. It's going to cancel itself out here. Now, what happens when you divide or multiply by a negative number? You need to flip your symbol around. So instead of greater than or equal to, this becomes less than or equal to. 16 divided by -4 is -4. So you just take your number, put it on the number line. It has an or equal to line underneath, so it's a filled in circle. And this says less than, so less than is to the left. And these two are done. Okay. On this next page, I'm only going to do these two at the top because these are just solving. We don't have to graph these, but these are going to be in, not in slope-intercept form. So we're going to need to move those into slope-intercept form, especially over here. So for the first one, if it just says solve and not graph, then you're just solving for the variable. So what do you do when you see parentheses? You do the distributive property. So this is saying 2 times x, which is 2x, and then 2 times -4, which is -8. Rewrite everything else you have, and we still need to get x by itself. So all we did was we distributed and got rid of those parentheses by using that property. So now, if you want to get the variable by itself, you move everything else away from it. So the first thing you want to move away is the 8. So the opposite of -8 would be +8. Cancels out there. We're left with 2x is greater than 20. I'm going to try and move my camera down a little bit. It seems to be readjusting a lot, or refocusing a lot. Maybe that'll help. We'll see. Okay, x is still not by itself. The only other thing we have to do is divide by 2 on both sides. X is greater than 10. So x could be any number bigger than 10, but not equal to. Now let's look over here at 3 because we've got x and y. It says to solve for y. So whatever you're solving for, you get that variable all by itself. So what we need to do is move everything away from the letter y. I'm going to start with the term that has the x in it, which is a 2x. Right now that is just a positive 2x, so I'm going to subtract it because you want to do the opposite. That way it's gone over here. Now the y still has a negative sign in front, so I have to keep that for now. I'm going to rewrite the symbol, and if I were to graph this, I would want it in slope-intercept form, so I'm going to write the x term first, but we're not going to graph this. That's just how I prefer to write it as an answer. And then we had the 8 that was already there. Okay, now y is not by itself. How do you get rid of a negative? Well, that's basically like having a -1 in front of your y. So we're just going to divide by that negative sign on both sides. Since we're dividing by a negative, we have to flip this symbol around. So y is now less than or equal to whatever we get on the right side. So -2 divided by -1 is +2, and the x is still attached. 8 divided by -1 is -8. Okay, so if we were to graph this, this is in slope-intercept form, we'd be ready to go, but we don't have to graph this. We just had to solve. Okay, now down here, I'm going to move on to a graphing question. We do have to graph the inequality, but we have to solve it first. Make sure to plot at least 3 points. Okay? So in order to graph an inequality, it has to be in slope-intercept form, which is that y equals slope times x plus or minus your y-intercept. Okay, so we want to get y by itself. So we have to move everything away from the y variable, like we just did in the last problem. I'm going to subtract 2x away, leaving y by itself on the left. My symbol is a greater than, and I want to put that x term right after the symbol because that is slope-intercept form, so it's a minus 2x, and the 2 was already there. So we're going to graph this, and we're going to start with our y-intercept, which ended up being a positive 2. So this is our slope, this is our y-intercept. Okay, you always start graphing, whether it's an inequality or just an equation, with making your y-intercept your first point. So from here, once you have your first point, you use your slope. So a slope of negative 2, if we're talking about rise over run, is like a negative 2 over a positive 1. So we're going to go down 2 over 1, down 2 over 1, 1, 2, and you always run to the right with slope, run to the right, down 2 over 1. So it said to make at least 3 points. Oops, I forgot we're going to do dotted or solid line. So with inequalities, since this is not an equal sign, like a regular equation, if there's no equal to line underneath, you're going to make a dashed or dotted line. If it does have that or equal to line underneath, you would make a solid line. Okay, so dashed or dotted, we have dashed, or sorry, dashed or solid, we have dashed because it just says greater than. So what this means is that y is any solution that's greater than this inequality. So in the video that you guys watched while I was out before break, it told you to shade in the region that represented all of your solutions. So if it's greater than, you shade above the line. If it's less than, you shade below the line. And if you're not sure which side to shade in, you could always test a solution out. So you could pick a point on this side or on this side, and you could take that x and y and plug it back into your inequality. If it works, then that means you are in the solution that has, or the region that has all of the solutions. What I tell people too is, if I were to take a ruler or a pencil and line it up with my line that I made, if I were to flatten that, anything above is greater than, anything below is less than. So if I were to flatten this line horizontally, everything over here would be greater than. So that's on this side of the pencil. I have a greater than, so I'm going to shade in that side. Everything in this region is going to be a solution. So if it's asking you to name 3 solutions, you're basically just naming 3 points in this region. So I'm just going to pick some clear points here. If I go over 2 and up 2, that's going to be a solution. I can do 3, 3. That's a solution. And I can even do 4, 4. So these are possible solutions to this inequality because they fall in the shaded region. And if you weren't sure still, you could always double check, since these are in x, y coordinate format, you could take these numbers, plug them in for x and for y, and see if you get a true statement. Okay, if it's true, then that means it's in the solution region. Okay, so the last thing we're going to do with these inequalities is graph systems. So all systems mean is that you have more than one inequality to graph. Besides that, it's still the same as the problem that we just did. They have to be in slope-intercept form, and then you have to choose between a dashed line or a solid line, and then you have to shade in your solution region. Okay, so I'm going to do the questions that I starred, which is basically just this question and this question here because we have to move some stuff around. So in this first one, we want to get y by itself. Okay, that's how we're going to be able to graph these. So I want to move the x's away from the y to the other side. If this is in standard form, I want them in slope form. So the first thing I'm going to do, I'm going to rewrite this inequality up here, x plus y less than or equal to 4. What I want to do is subtract x on both sides, leaving y is less than or equal to negative x plus 4. So that's one of my inequalities. The other one is this one here. So I'm going to solve it in this space to the right. I'm going to subtract 3x from both sides, leaving a negative y is less than or equal to negative 3x plus 3. Okay, I want my x term right after the symbol or the equal sign because that's going to give me my slope. So now I have a negative y. I can't have something by the y, so I need to divide both sides by negative 1 to get rid of that negative sign. When you divide by negative 1, it's just going to change the sign on everything that's on the right. It's not going to change the numbers. So basically, let me use the room over here. Negative 3 divided by negative 1, positive 3. And since we are dividing by a negative number, we've got to flip our symbol around. Okay, from less than or equal to greater than or equal to. So we have 3, positive 3x, 3 divided by negative 1, negative 3. So here's what we're going to be graphing. This inequality and this one here. So it's the same thing as what we just did here, except now we're going to have 2 of these and then 2 regions to shade in. Okay, I'm going to start with this one. My y-intercept is positive 4, so I'm going to go up here, make a point on positive 4. My slope is a negative 1x, so that means a rise over run of negative 1 over 1, down 1 over 1, down 1 over 1. And since we have an or equal to line underneath, this is going to be a solid line. Okay, and let's see which way we're going to shade this in. This is saying y is any solution less than or equal to this inequality. So less than is going to be underneath. And just to double check, I can use my pencil, flatten it out. Okay, less than is underneath, which is going to be this side of the pencil. So if I straighten it back out with my line, this side of the pencil is over here. So it's going to be this whole big region here. Now that's just one inequality. Let's see what the other one tells us to do, because we're going to look for where they overlap. And that's going to be our solution to the system. So for this inequality, my y-intercept is a negative 3, and the slope is positive 3. So that means a rise over run of 3 over 1. Up 3 over 1. Up 3 over 1, because it's positive. So we're going to start at the y-intercept, 1, 2, 3, over 1. 1, 2, 3, over 1, 1, 2, 3, over 1. And we have the or equal to line underneath, which means this is also going to be a solid line. Okay, now let's see where this is going to have a shade in. Now this says y is any solution that's greater than or equal to the line we just made. So greater than, if I were to flatten this line out, greater than would be above my line, which is this way. So it's going to be this side of the pencil.